Assalamualaikum warahmatullahi wabarakatuh. Hello everybody, my name is Muhammad Irfan bin Cik Rani. As you guys can see here, and I'm from Mathematics 1, my program. And I'm also program from PPSMP from June 23 until 2028. And today I'm here to present my task 2 work, which is essay writing about uh, vectors. Today I'm going to present about my algebra vector, which is the topic that I choose today is projectile vector, and I hope that you guys find this thing very interesting to see. So let's go. So let's continue. So of course, before we move on to further knowledge, we need to know about the introduction of vector first, so we can deeply more understand about vectors. So here we go first. A vector is defined as an object that has two important things, namely direction and magnitude. A vector can be imagined as a segment that is directed and has a length that is the magnitude of the vector, and also shows the direction with the arrow. The direction of the vector starts from tail to the head of the arrow. So, like I say here, I present you with an image to really make you understand more about it rather than just reading a text. So you guys right here can imagine this whole arrow represented as the magnitude, as the also as the direction. Magnitude and direction combined also mean as the value of the object moving in certain direction. For example, like if I take this arrow here, it goes to the west direction. So I know what is the speed of the object moving towards the west. Here, the magnitudes play the role, which is, for example, like 30 meter per second to 400 meter per second, whatever kind of speed you want it to be. So here, is the tail here, which is don't have the pointy point over here, and the pointy point over here is called the head or sense, which is show where the direction will be, called the head. So let's move on. Two vectors are the same if they have the same magnitude and direction. This means that if we take vector and translate into a new position, which is through a process called translation, if you learned it in the middle schools, which is exactly the same direction and magnitude, but it just in different position, which is like if we put it on the graph cartest, it will be like in the different, like above the axis or below axis, it will be to the same thing. So now, without rotating it, like I said, it's just different place. Without rotating it, without changing the value or anything else that we do to it, then the vector we obtain at the end of the process is the same vector we had in the beginning. I'm sorry that I don't provide with image, so I hope you guys can understand it as well. So let's move. All right, everybody. So we're gonna continue to our third slide over here, which is representation of vectors. So here we have vectors are represented by taking an arrow above the quantity, which is, for example, here, i.e., force vector is represented as where the arrow above F represented as F, like the image right here. Wait a minute. So I'm taking a laser over here, which is this an arrow that is a vector quantity. The arrow above the F is represented as the force of an object that moves in certain direction, which show how much the force need to use for an object to move at that speed. Vectors can also be represented by taking their respective magnitude in x, y, and z direction, which is also called as the three dimension. If we have two dimension only, we have only x and y. The x direction is shown using the eye, and also have, like say, vector has an arrow above it, like this one pointing above. Similar to the y direction, it shows using the j, also have an arrow above, and the z direction is showing using the k. I'm sorry, which is not full image over here, but it has an arrow above it. Now the vector a is represented as a, an arrow above it, and equals to xi equal plus yj plus zk, which is an formula for the calculation of the vectors. The plus of the x direction, which is vertical, y direction of the vertical, x direction of the horizontal, and z directions toward 90 degrees beside the horizontal line, form another horizontal line. Like as it said from this statement here, we have three dimension, but it is only say three dimension vectors. Two dimension of vectors, like example, I say we have y direction, y line here, vertical line, and also x vertical line. This two dimension, which is only a 90 degrees one, is only two dimension because we cannot it doesn't feel like point out, it doesn't feel like real. But when we add the z line, the z line here, when we have this one, it points towards another line. It's formed like a cube. For example, like a cube. Like say, for example, if we take a example like cube, that is 3 dimension because it has 3 lines above vertical and 2 horizontal point towards another one, and the difference, the angle of the 2 horizontal line is 90 degrees. If we want to, like, if a cube is 3 dimension, what is the 2 dimension of a cube? 2 dimension of cube is a square, because cube and a square is the same. They have the same length of the sides. So the square is actually two-dimensional on the time two-dimensional of the square. Here, the point where the vector starts is called the trail of the vector, and the end point of the vector is called the head of the vector. We can also denote the vector as the coordinate point in 3 dimensions. So I hope you guys understand it. Let's move on. So right here we have the magnitude of vectors. The magnitude of a vector represents the strength of the vector. We can calculate the magnitude of the vector by taking the square root of the sum of the squares of each component in the x, y, and z directions. The magnitude of a vector is calculated by taking the square root of the sum of the square of the components of the vector in the x, y, and z directions. I think it's like basically meaning that we need to use the x and y and z to calculate the really value of the x, y, and z, so we can get the exact point of the vectors, what is the magnitude, what is the direction is. For any a equals to ai plus bj or ck, actually it's denoted as a, b, and j, while before the slide it's denoted as x, y, and z is the same things. You guys don't need to worry. The magnitude of the vector is represented as modulus a over here, and its value is right here. Modulus a equals to cert over here, which is square root of in the parentheses over here in the bracket. I'm sorry, a squared plus b squared plus c squared close bracket. So I hope you guys understand about that. So let's move on. Alright, so we're gonna continue to our first slide over here. So right here we're gonna learn about representing vectors quantities over here. We can represent a vector by a line segment. This diagram shows two vectors. Like I say in the second slide, I think vectors can also represent as when a line is formed, and in that line there's also an arrow drawn at it. It's called as vectors because in that line it shows like an object, like denote as an object moving towards to a certain direction, east, west, north, or whatever you want to call it, south, east, example. And it shows like in that the direction how much what speed the object is moving towards to the direction. So right here we're going to continue. We have used a small arrow to indicate the first vector is pointing from a to b. A vector pointing from b to a will be going in the opposite direction. Sometimes we present a vector with a small letter such as a in a bold typeface. This is common in textbooks, but it is inconvenient in handwriting. In writing, we normally put a bar underneath or sometimes on top of the letter A or A. Like it's only A over here, but I think it has an arrow above it. I hope you guys understand it. In speech, we call this the vector as a bar. For example, if we hear about somebody called about in magnitude, we call a bar. It is called as an A with an arrow above it, like in the previous slide. Hope you guys understand it. It is called that, so don't be confused. So right here we have the position of vectors. Sometimes vectors are referred to a fixed point and origin, such as vector is called a position vector. For origin, which in coordinate it's also known as 0, 0. So we might refer to the position vector at a point P with respect to an origin O. In writing, might put OP for this vector. Alternatively, we could write it as R. Those two expressions refer to the same vector. If you want to fully understand about vectors, we can go from point O to point P, which is OP over here, and put a line above it, so we know it is a vector that is moving from O to P point, or point to P point. It also can be known as R, as if you really don't want to write it as a long sentence or word, put or symbolize it as R, a single letter. So here we go. So right now we're going towards to adding two vectors. One of the things we can do with vectors is to add them together. We shall start by adding two vectors together. Once we have done that, we can add any numbers of vectors together by adding the first two, then adding the result to the third, and so on. In order to add two vectors, we think of them as displacement. We carry out the first displacement and then the second. So the second displacement must start where the first one finished. So right here, if I'm going to take a pen over here and go color yellow. Right here, we have the A point, A line, which is the point of A having the arrow over here towards any certain direction, and also this is a line of B pointing towards a certain direction as well. It will be like included in this picture over here. It is represented as a full image over here. So from this image we understand that A is a line in pointing towards this direction. So we see this is the same picture of A, so this will be A. I'm gonna erase it a little bit, kind of crowded. So here also this B over here, also the B point. So right now, like if you begin to search this one, it will be easy. For example, like we don't know the point of it, we don't know what's the value of it. So right now we know that this vectors plus here is from this point ends toward this point. It's the same thing. This line also start from this point. I'm going to go with 3. It starts from here and ends from here, which is the same. I can erase it a little bit, which is the same. Start from here and ends from here. This line, two lines adding up together is the same as this one. It's in at the same point. So example, we don't know this one, I'm sorry. We're gonna add this one to get the real magnitude of this one. What is the length? So here we're gonna add up of the point A, which is gonna symbolize as A, and this one as B. So if we add up together with the arrangement of the line over here, we have the opposite line, which know it is as a positive. If it going opposite of the arrow, which is where it's going, it will be negative, but it is going through as the arrow point at, so it will be positive. So A plus B is equal to the direction of this point, which is the magnitude of it. So right here we erase this thing, like I'm sorry, like I did before. It will be A plus B, like say this magnitude plus this magnitude, and at this point, start from this point, and at this point it is the same as this. A plus B start from here and from here, but it's in more nearer direction. So let's move on. So we're going to continue at our vector addition more. I already explained it before, but I'm going to explain it more so you guys can understand it a little bit more. So longer vectors mean larger magnitudes. Smaller vectors mean smaller magnitudes. Of course, it is also as a normal thing to know. The vectors don't have to be next to each other in order to add them. They just have to be going in the same direction. So here we are. I'm going to explain it with a picture again. Right here we have the image of like a stair over here, and suddenly it becomes this one. Like how it is possible? So now if we make it as simple, like I said, vectors start from one point and end to another point. So right here, if we see here, the point is towards here. So it must start from here and ends at this final point. Like I say also as well, start from here, ends at this point, which is really the same side if we line it together up here. I'm sorry, but this image like a little bit off, but it's kind of same thing. So now if we group of the horizontal line and vertical line, we can get from this to this one. So like let me explain more about it. So now if we have this one over here, vertical lines, which is 1 meter, 1 meter, 1 meter, add them up together, we will get this one. For example, like 1 meter over here, and another 1 meter, and another 1 meter. This is 3 meters. And then we grew up the vertical line. Now we will get 1 meter over here and another 2 meters over here. And all of that up together will be this one, which is 2 meters. It's all at together and then start from one point and end at one point, which is this one is the same one, starting from a point and end at the end point, which is the same place of point. So let's move on. All right. So here we are. We have length, force, and velocity of vectors. We're gonna learn about after we learn about direction. We're gonna learn about force. What is the speed, the force of the object moving towards a certain direction. So now we have vectors represent the force and velocity, and these things are in a certain direction. For example, the vector r has direction and length unlike a scalar. The length in the vector based on the geometric knowledge of the position R is modulus R, or in the previous one we know as modulus A, which is the same thing. As long as we understand about it, we just replace the letter, so don't be confused about it. Equals to square root of x squared plus y squared plus z squared. Sorry, right here. Hope you guys understand about it. Like before, it's also as a squared plus b squared plus c squared. It's just the same thing, but change the letter, so don't be confused. And from Wong 2013, which is he said state about this word. So here we have the vector v is shown on the grid of unit square. Below, find the value of modulus v over here. From this thing, it seems like kind of same, like sort of. As you guys can see, it is same. It is also known as the Pythagoras theorem. If we can see it is just the same. Really, it's just the same. Just want to know the magnitude of this one, like Pythagoras theorem as well. We just want to know the value of the hypotenuse of a triangle. So it is the same thing. So I know we have two vectors have inclined support and the length difference will not be equal. Not only that, two vectors that have different stances, even in support is parallel, and the same length will be still be different, which is stated by Neri and Mitchell from 2010. So move on, we have collinear vector. Furthermore, collinear is used as synonym for a parallel. This shows that the vector have parallel and equal lines of action. In addition, parallel vectors that have the same direction will be called like vectors. There is a scalar for a collinear vector like b equals to k as a scalar, which is stated here with a scalar k, and absolute value of k is the ratio of the length of the same and two collinear vectors, which is from JHA 2005. Example picture of scalar for collinear vector, which is we have example picture over here. For example, I would really like to explain it more. Understand? We have two line has the same thing. Just assume this thing has the same position. So right now we have two lines. How do we know they are equal? So we use a scalar like this one, b equals to ka. So I'm sorry, this is a. So this is the line a and this is line b. So how do we know this is collinear? If we put the value of a in here and put the value b in here, and we get the value of k, when the k has a value is a collinear vector, which is, I'm sorry, this is supposed to be longer. So we can know what's the ratio between b and a. K is like an add of the ratio between two lines which has the same position and point direction. So now a and b has same direction but different length. So k is the one who determine what is the ratio between line b and line a. So let's move on. So right here we have use of vector in daily life. Right here, first we have banking of roads. A road at curve is elevated at the farther end of curvature. The angle of banking is theta. The normal reaction from the ground is n. The vehicles are inclined to vertical by angle theta, and cos theta balance the weight mg of the vehicle, which is the formula of weight in physics, vertical by angle theta, and cos theta balance weight and sin theta supplies the centripetal force along the radius of curvature that determines the maximum speed of the vehicle to avoid slipping. Like when we have like a slope of mountain, like a really steep of a mountain, we use this kind of formula to determine what kind of speed that we need to use to at the center vehicle to get on top of the hills without slipping. So we also have projectile motion, projectile stone thrown with an initial speed u at angle theta, where the horizontal has a vertical component of u sin theta minus gt, which is here formula we will learn next also. G is equals to the gravity force. Also we live in earth, of course we have gravity force that fighting towards our speed, so the object will not go out of space, and the horizontal component of u cos theta and the components of vector. Also, we have sharpening with a pencil with a blade. We cut the pencil at an angle. The component of force in the direction perpendicular to the pencil cuts the pencil. The component of force in the direction parallel to the pencil remove the thin wooden part. Earth magnetic fields also a vector. Earth magnetic field has two components P and H, perpendicular to a surface and parallel to the surface, which is fighting off the solar beam from sun that protect us. Pendulum, the tension in the string has two components, balance the weight and give the centripetal force. So Here we are continuing about daily life application of vectors. Flowing are the everyday application of vectors in daily life. Navigating by air and by boats is generally done using vectors. Of course, when we're moving the object, boat or plane, we have vectors. We have direction we need to go. Planes are given a vector to travel by and they use their speed to determine how far they need to go before turning or landing. Flight planes are made using a series of vectors. Sports instructions are based on using vectors. For example, wide receivers playing American football might run a route where they run 7 meters down the field before turning left 45 degrees and running in that direction. Sports commentary also depends on vectors. Only a few sports have fields with grids, so discussion revolves around the direction and speed of the player. So what is meant is, yeah, here we have the field of the football over here and we have goals. I mean the goals like this one in football, right? We must calculate what direction of the player running. So like vectors, so for example, a player from here and a player is run towards here to trying to reach the goal. So they need to calculate how much speed they are running. So when they toss the ball, it will be received by the player to send to the goal. So they will get the point, right? So you guys understand about it. So we have more about the existence of issues related to vectors recently to solve problems. For example, in military, something called artillery that fires projectiles, such as pistol, rifles, or other type of propellants that use explosive application is considered a cannon or a firearm. A mixture of the types of cannon in the military to ensure the characteristics of a tick card to produce a perfect tick card. Vectors are necessary to calculate where the bullet will go and where it will hit the ground. Vectors objectives. So we're going to hear about what is the really point of vectors. The objective of studying vectors is to be able to find the direction movement of a body or object and its magnitude, which is represented by the velocity or acceleration of the body or object. Vector can also easily solve geometry problems. Like this, the example of problem that I said before about calculating about the value of a two line have like a triangle. The adding of two lines is equal to one line, which is the nearer way to reach and the end point, like that. So here we have vector projectiles activities. So quantum linear multiplication of vector equation has formed the two equations for object that accelerate uniformly named v squared equal u squared plus 2s and a times s equals v times u and more, which can be used for the problem of a gun bullet and an archer's arrow. The equation for flight time is t1 t2 equals to 2s divided by a, which is from Winners 1961. Right here we have the formula like it's also stated here, v squared by u squared and etc. It is like a physics formula, and projectile vectors is actually related to physics or more, more deeply rather than it's just only mathematics. It's related to physics more because we need to calculate about the angle and the speed of it. So really important physics to know what is the projectile so we can aim the bow, arrow, or gun more accurately. So right now we have the vectors for flying objects. The velocity vector shows the direction of the object velocity as we discussed. If it's moving at a constant velocity, the vector won't change. But if the velocity changing, the arrow will too. For example, like here, if we throw balls, for example, this like 50 meters per second, at the end it will lose energy. Finally it will be 20 meters per second, which is will be going downward because it's losing, so it's also being pushed by the gravity, so it will land on the ground. Also, we're going to learn about vectors for flying objects. The ball in the video was moving in two directions at once. Each direction component is to component its velocity. Let's look at them. So right here, like say, there's an existence of gravity when it's from 50 milliseconds, from 20 milliseconds being pushed. The direction of the towards point each other is going down, not because of its this one, but it's losing the speed of the vertical line, the one here. So losing that one is this constant of the x, but it's losing the speed or the energy for the vertical line. So that's why it's being pushed. It's overwhelmed by the gravity, and that's why it's end on the ground. Hope you guys understand about that. This thing slide over here is also the same as before. It's only pointing what happened to the ball. Like say it's being pushed by gravity, it's the constant of x being pushed. It's also the same, so let's move on. So right now this is also the same. Just want to point more because to understand about it, this is the value of the formula like here. when there's the speed of the gravity times phi over here, this equation will be used for questions involving vertical motion. Like I said, the vertical motion is it's changing in this one. It's the same thing. But this one, I'm going to explain like here. Like I said, the acceleration will always be pointing down. This is why the trajectory looks like in upside down parabola y equals minus x negative 2. Why is equal negative x2? Because it is defining or opposite direction of what we want. As for example, when we throw a ball, it always go up. So that's why it is positive. Positive is up. But when it's down, it's fighting our direction of point, it equals negative. So that's why gravity is equal to negative, because fighting the direction that we want the ball to go, which is upwards, but because of the gravity the balls go downwards. So let's analyze about the question we want to learn today. Analysis of vector projectile motion. Find the maximum height and initial velocity of the stone throw in vector form. A stone thrown in a horizontal line with a velocity of ui plus uj, ms from a fixed point on the horizontal line, and O has hit the ground at a point on the line 440 meters away. Find the value of u and the height of the stone at the highest height h. Use g equal to 9.81, which is the speed of the gravity, like I said before. Let's go through an example of question. The movement of stone can be introduced by stating the velocity, acceleration, in vector quantities like the two equations below. So we have two equations that we'll be using in the question. So let's move on. So here we have, and the laws of motion are applied, in vector form. Can change this one. Rock motion governed by vector law should be considered as s equal to ut plus 1 per 2 at squared. Substitute u, x equals uv, and u equals to u, and ax equals to 0. Why ax is equal to 0? Ax is actually our first speed, our speed of object in the first place. For example, in here we are throwing a rock. What is the speed of a rock when we are throwing the rock at our hands? Of course it's 0, right? So that's why it's equal to 0, because we are holding the rock at our hand. It got no speed, it got no any magnitude value of speed. So when we throw it, this is the final velocity, which in the air is only being affected by the speed of the gravity, which is the full speed. That's why the object is falling down, because it's affected by the maximum speed. Then 9.8, ignore the negative, but we only take the point, the number here. The maximum point of the value of speed is 9.8. So the equation will be s right here, s I equal syj is equal to u. We have u, our first velocity, ux plus uy j over here, equal times t plus 1 per 2 in a bracket axi plus ayj equals t squared. So right now we substitute our first here into this one, like in the previous slide, and 9.8 into this slide. So that's we need to get the formula step by step. So like this question say here, we have the coefficient which is 440 in horizontal plane motion, and coefficient j which is 0 vertical plane motion. Why our coefficient is 440? Because it is the final distance of our object travel at the end point. So here we have 0 kilometers, 0 meters, and finally we reach 440 meters is our final distance. So now it's presented as u times t, which is our distance or speed, like that. We got 440, it is both of it. So we put in the equation, which is ut over here minus at, which is after we times 1 per 2 times 9.8, we got 4.9, and it will negative because it is the gravity, it will be negative because gravity is opposite of our direction of balls. So after that, we get substitute t squared equals 440 divided by 9, because when we push the negative to here, we get positive, and then 4.9 will be 440 will be divided by 4.9, so we get this one. After that, we square root both to remove the square, and then we substitute t. We get t equal to square root 440 divided by 4.9 into this one to get the point of u. After that, we get 440 divided by 440 square root 440 per 4.9, because t will be down here, and equal u will equal 451.439. After that, we can find the highest point height of the stone. Calculate when the stone reaches the height of 0, velocity means v equals to 0. So this means from the vector law of motion, we will get this equation right here. From the first one, we get 51.439. After that, because in only j, we got the value of t, so we only collect j and equal to 0, because we know the final velocity, first velocity is 0, so that's why we equal to 0, and then we calculate the value of t, so that's what we get. So right now we're going to go to find the highest height of the rock. So it is in the question, so we need to find the height. So now we have the formula of the physics, which is to find the height right here, the formula of physics. So we only substitute the value of u and g and t, which is u we get for 51.439, so t we get 51.439 per 9.8. So when t here t squared, so we need to square it, and g is 9.8, which is the value of the gravity. So we get these values, and it will be minus the both of these, we get 128. So therefore the highest height each stone is 128 meters. So this is the conclusion of what we get. So in conclusion, we need to take into account the gravitational acceleration factor that acts towards the center of the Earth when we want to calculate the speed of the projectile and the height of the projectile thrown or shot from a certain height. And at a certain angle, the change will greatly affect the direction and speed of the projectile. Therefore, the involvement of physics formula, like I say, very important, because we involve the acceleration of gravity, which is known as going to be used in physics formula. We cannot solve with normal mathematics formula. A vector is constantly applied to something that tends to be a more abstract and direct line in the three dimension, which is from Craig 1951. That's all from me. I hope you guys understand about my presentation today. Thank you for much for